Welcome to Mole Conversions Video 4, Two-Step Mole Conversions. Our example problem says how many atoms are in 540 grams of aluminum. Anytime the two things that we're converting between don't involve moles, we're going to have a two-step problem. And this is when it can be useful to look at our mole diagram to help us figure out what we need to do. So we're starting with mass in grams, and we want to go to atoms. So if we look at the mole diagram, we are starting over here at mass, and we want to end up at atoms. So that means we're going to have to convert from mass to moles, and then once we have our number of moles, convert to our number of atoms. So the first thing I need to do is convert from mass to moles. So I start with my given information, 540 grams of aluminum over 1 times, again, if we want moles have got to go on the top, grams go on the bottom. To convert between grams and moles, we need to use molar mass. If we look at aluminum has a molar mass of 26.982 in 1 mole. And then I'll solve this out to determine how many moles of aluminum I have. 540 divided by 26.982 gives me 20.0133 ... moles of aluminum. I recommend keeping the full number in your calculator as you do this and rounding at the very, very end. Next up, I need to then take my moles of aluminum and convert them to atoms. So I take my 20.0133 etc. moles of aluminum, and then I need to convert it to atoms. So I want atoms, so it goes on the top. I have moles, it goes on the bottom. The conversion factor between moles and atoms is Avogadro's number, where 1 mole is equal to 6.02 times 10 to the 23rd atoms. When we multiply by Avogadro's number and round to correct sig figs, we get 1.20 times 10 to the 25th atoms of aluminum. What I just showed you, I broke this into 2 separate steps. You don't necessarily have to do that. You can make this all one big step. It's kind of a personal preference on which you prefer to look at. If I was going to put this all into one big conversion, 540 grams of aluminum over 1, multiply that by 1 mole of aluminum, which has a mass of 26.982 grams. Grams cancel. Then I would multiply by Avogadro's number, 6.02 times 10 to the 23rd atoms over 1 mole. Again, moles cancel, and we're left with just atoms at the end, which once again comes out to 1.20 times 10 to the 25th atoms of aluminum. So when you have these 2-step mole conversions, you can literally do it as 2 steps, like I showed you at first, or you can kind of turn it into one long dimensional analysis problem. Either way is a correct way to do it. And that concludes our video on two-step mole conversions.